Hi, it's Ms. Trevino again, and today I'm going to be going over the Unit 2 and Unit 3 portions of the 2020 Physics Midterm Study Guide. In the last video, I went over Unit 1, Linear Motion, and so again, this time I'll be going over Unit 2 and 3. Number 21, what is a projectile? A projectile is basically anything that's in the air. It's going to be anything in the air that is affected by gravity. Number 22, acceleration acting on a projectile is always directed. Well, we care about acceleration, and then we care about anything that's in the air. So the acceleration affecting anything in the air is always going to be gravity, negative 9.8 meters per second squared. So it's always going to be directed downward because gravity is negative 9.8 meters per second squared. That's the acceleration. Number 23. A freely falling object starts from rest. What is the velocity of the ball that is in free fall for 5 seconds? Well, we're looking for the velocity of a ball that is in free fall for 5 seconds. That's our time. We're looking for velocity. It's in free fall, so that means its gravity has to be negative 9.8 meters per second squared. That's what it's affecting it, the gravity. So in our formulas, we can choose to find the velocity with the first one. Vy equals gravity multiplied by time. Vy is what we're solving for. We know our gravity is negative 9.8, and our time is 5 seconds. So all we have to do is negative 9.8 times 5, and that gives us negative 49. So our velocity would be negative 49, which means it's falling down, meters per second. Number 24. After falling for 8 seconds, what speed will it have? So now we know we're falling for 8 seconds. We're going to use the same formula at the top. We're looking for its final velocity because speed is velocity. Gravity is still negative 9.8. That doesn't change. Our time is now 8 seconds instead of 5. So all we have to do is negative 9.8 times 8. We get negative 78.4 meters per second. Number 25. A ball is thrown vertically upward with an initial velocity of 30 meters per second. What is the maximum height reached by the ball? So we're looking for height. That's going to be our distance. And since it's going up because height goes up, that's going to be our dy. We know that we have an initial velocity of 30 meters per second. And that's really all we're given. So this is a 2-problem question. So the first thing we're going to have to do is find our time. Because if you look at the formula for dy, it has time in the equation. We don't have time. We need to find time. And we're going to do that by using our velocity. Vy equals gravity multiplied by time. We can rearrange this by dividing gravity from velocity to solve for time. So this is the formula we're going to use to solve for time, Vy over gravity. Our velocity was 30. Gravity is negative 9.8. So our time would be negative 3.061. But can you have a negative time? No, you can't, because time can't be negative. There's no way we can go back in time, so we'll just change that to a positive. So it's 3.06 seconds. That's our time. That's not our answer. That's just the time we need to solve for our dy. So in our second problem, we're going to use the formula dy equals gravity multiplied by time squared over 2. Gravity again is negative 9.8. Time is 3.06. We're going to square the time, only the time, nothing else but the time. And then we're going to divide by 2. So when we're plugging in our numbers, 3.06 squared times negative 9.8, divide that by 2, and we should get negative 45.88. Now, yes, we got a negative number, that's fine. When things fall down, they go downward. That's how we get the negative. But since we threw the ball up initially, we want to know the maximum height it can reach. So all we have to do is just take out that negative number. So 45.88 meters. That is our answer. If you forget to take off the negative on a test, that's fine. You should still be able to get the points. Number 26, if you drop a feather and a coin at the same time in a vacuum tube, which will reach the bottom of the tube first? Well, we're dropping a feather and a coin, but it's in a vacuum. That means there's no air. That means there's no air resistance. So since there's no air resistance, both will hit the ground at the same time. Why will both hit the ground at the same time? Because there's no air resistance. Remember back in the video we saw of the astronaut dropping the feather and the hammer on the moon where there's basically no air resistance? They both hit at the same time. This is the same scenario. We're dropping a feather and a coin. If there's no air acting on that feather will drop at the same rate the coin will. That's why they hit the ground at the same time. Number 27, an object free falls from a building towards Earth. In how many seconds will it reach a speed of 55 meters per second? Well, in this problem, we want to know how many seconds, so we're looking for the time. Will it reach a speed of 55 meters per second? Speed's the same thing as the velocity, and it's falling. It's in free fall, so that means the only thing affecting it is gravity, which is negative 9.8. So we're looking for time, we have our velocity, and we have our gravity. Again, we're going to be using our Vy equals G times T formula. We just have to rearrange it to solve it for time. So if we have Vy equals gravity multiplied by time, to find time, we're just going to have to divide gravity. But let's plug in our numbers first before we actually solve. So Vy is 55. That's going to equal our gravity, which is negative 9.8. And our time is what we're looking for. So again, all you have to do is divide by negative 9.8. That cancels out over here. So 55 divided by negative 9.8, that'll give you negative 5.6122. So our time is 5.6122. Remember, you cannot put a negative for time. Time does not have a negative value. Technically, our velocity should have been negative since it was going down, and if it's in the downward position, that's how you get your negative velocity. So a negative times a negative would cancel it out. But you can never put a negative in front of your time. If you do that on the exam, you will not get the credit for that question. So no negatives for time. Number 28, the acceleration due to gravity on the moon is 1.62. What is the distance the object free falls in 12 seconds? So we know our gravity this time. We know our time. We're looking for the distance the object is in free fall. So we're looking for our d, distance. And since it's falling downward, we're looking for the distance in the vertical direction. So we're looking for dy. On our formula charts, we're going to be using our dy equals gravity multiplied by time squared over 2. Because that's the information we're given and that's what we need to find. So dy equals gravity multiplied by time squared over 2. Plugging it in, gravity is 1.62. Time is 12 seconds. And our distance, divide that by 2. So when we're plugging in our formula, 1.62 times 12, that gives us 19.44. Ooh, sorry. Time was squared. I almost messed up on that one. Sorry. So 12 squared times 1.62, that gives us 233.28. Then we'll divide that by 2. That gives us 116.64. So that's 116.64. And since we were looking for a distance, it's in meters. Now it's going to be okay if you get a negative dy because yes, it's falling down. So if you get a negative for the displacement, that's perfectly fine. That means it's going down. So this one can be answered in a negative. The only ones that cannot be answered in negatives are time. Time is never negative. Number 29. A ball is tossed straight up in the air. Describe the ball's vertical velocity and acceleration at positions A, B, and C. So when you're throwing something in the air, the vertical velocity has to be a high positive number. And it has to be high because if it's not fast enough, it won't go up in the air. We can't throw something up with 0. And it has to be positive because it's going in the upward direction. As it reaches position B, remember, just before it comes back down, its velocity is going to be 0. That's because it starts off high, the velocity, and as it's going up, it's going to start to slow down because gravity's pushing down on it. So it starts off at 40, 30, 20, 10. Finally, it'll be at 0. And as it comes back down to position C, well, it has to be a high number again because gravity is making it go faster and faster as it goes down. But this time it'll be a negative number. And it should be the same velocity it was as it was going up, just in a negative number. So as we're going down, it's 0, 10, 20, 30, 40 meters per second. But it would be negative since it's in the negative direction. Now, acceleration is what is affecting that velocity. And acceleration never changes. It's always going to be the same number because the acceleration affecting anything in the air is always going to be negative 9.8 meters per second squared. It will always be that number no matter where the object is located. At all points, it's going to be negative 9.8 meters per second squared because that's the gravity. Number 30, at what part of its path does a projectile have minimum zero vertical velocity? So when does it have zero vertical velocity? Well, we just said that in the top problem. It's going to have it at position B, which is the highest point. So at the highest point, just before it falls back down, it's going to have zero velocity. So that was all the questions for Unit 2. Let's go ahead and do Unit 3. Unit 3 is over projectile motion, and it's just one page. Number 31, in the absence of air resistance, the angle at which a thrown ball will go the farthest, maximum range. So in this question, we're looking for the angle that's going to have the most farthest maximum range. That's the dx. And the angle that's going to make it go the farthest is always going to be 45 degrees. If you need to, go back and look at your notes to see what other angles are going to cause the ball to do other things. For example, if I was looking for the maximum height, it would be 90 degrees, not 45. Number 32, a baseball was dropped from the same height and at the same time that a baseball was thrown horizontally. Which will hit the ground first? So let's draw what that looks like. We're throwing a baseball down, and then we're throwing a baseball across horizontally. But it's still going to fall because of gravity. So which one's going to hit the ground first? Again, think about what the question's asking. They're both being thrown, one's down, one's across, but they're both being affected by gravity, so they will both hit at the same time. Again, they're both going to hit at the same time because gravity is affecting them both equally. Gravity is pushing down on them at the same rate of negative 9.8. Number 33, a cannon with a barrel velocity of 350 meters per second launches a cannonball horizontally from a tower. Neglecting air resistance, how far horizontally will the cannonball have fallen after 3 seconds? So let's look at what we have. It's thrown with a velocity of 350 meters per second. So that is our velocity, but it's thrown horizontally, so that's our Vx. Remember, in projectiles, you have your x's, which is horizontal, and you have your y's, which is vertical. X is going to go up and down. I'm sorry, X is going to go left to right. Vertical is going to go up and down. So back to number 33. A cannonball with a barrel velocity of 350 meters per second launches a cannonball horizontally. So that's our Vx. Neglecting air resistance, how far, so we're looking how far horizontally, will the cannonball have fallen after 3 seconds? How far horizontally is our distance? And since it's horizontal, it's our distance in our x direction. And we know our time is going to be 3 seconds. So in our formulas, we're looking for Vx, not Vy. So we have to use our Vx equals dx over t. So Vx equals dx over t. Dx was 350. Time was 3 seconds. So on our calculator, 350 divided by 3, that's 116.66667. So I'll do 116.67. And since it's our velocity, it's meters per second. Oh, I'm so sorry. I did this the wrong way. Unit 3, projectile motion. Number 31. In the absence of air resistance, the angle at which a thrown ball will go the farthest, which is maximum range, is going to be, well, we're thinking about angle, and we want the farthest maximum range. Remember, range is an x. So we're looking for the farthest, which is our distance, range, x. With this one, you need to go back to the notes and look at the angles and how the angles affect the distance going up into the air and the distance going across horizontally. The angle that's going to go the farthest is going to be 45 degrees. That will always give you the farthest distance. Number 32. A baseball was dropped from the same height and at the same time that a baseball was thrown horizontally, which will hit the ground first. So let's look at what that looks like. We have a baseball going straight down, and then we have a baseball being thrown horizontally, but because of gravity, it has to go down. So this is the scenario. Now pay attention. Which will hit the ground first, meaning which is going to fall downward first? Well, the only thing affecting them going down is gravity, negative 9.8, and it's going to be affecting them both equally. It's going to push them both downward in the downward direction equally at the same rate. And because of that, both will hit the ground at the same time. And again, that's because of gravity. So again, both will hit the ground at the same time because gravity is affecting them both equally. Number 33. A cannon with a barrel velocity of 350 meters per second launches a cannonball horizontally from a tower. Neglecting air resistance, how far horizontally will the cannonball have fallen after 3 seconds? We use the word horizontally twice in this problem. So let's focus on that. I want to mention that in projectile motion, we were throwing things out and down. So they were being affected in the x direction, which is horizontal. That's affecting anything going left and right. And then we were also throwing them down. Again, that's y. That's for vertical. And that's anything that was going up or down. So in this problem, the cannonball has a velocity of 350, but it's shot horizontally. So that's not just velocity, but that's Vx. We want to know how far horizontally, so how far is our distance? But since it's horizontal, we're looking for our dx. And then time is in 3 seconds. That's just time. So in our problems, we have Vx, we're looking for dx, and we have t. We can't use any of the Vy's because we don't have y's. We're not vertical, but we do have the x. So we need to use the dx formula. dx equals vx multiplied by t. So dx equals vx, oops, multiplied by t. Sorry for that. So when you're plugging this in, vx equals 350, our time equals 3 seconds. So 350 multiplied by our time, 350 by 3, is 1050. And then our distance is measured in meters. Number 34, a projectile is launched horizontally with a velocity of 7.2 meters per second, 5.6 meters above the ground. Calculate the projectile's time in flight. So we're looking for time. We know it's launched horizontally with a velocity of 7.2, so that's our Vx because it's horizontal. 5.6 meters above ground. Above ground means it's going up. So 5.6 is our distance, but in the y direction. And of course, we always know that gravity is negative 9.8. Okay, so we're looking for time. We're given a Vx, a dy, and we know gravity. Let's look at our formulas. That's not solving for time, but we could use it. That's not solving for time, but we can use it. This one is solving for time, and it uses 2 dy, which we have, and gravity, which we know. So we can use this one. Vx equals dx over t, that's not solving for time. Dx equals Vx over t, that's not solving for time. But we can rearrange these if we wanted to solve for time. But since this one's already written for us, I'll go ahead and use that one. Time equals the square root of 2 dy over gravity. So the square root of 2 times our dy is 5.6 over our gravity, which is 9.8. Remember, you can't put a negative under a square root or you're going to get an imaginary number. So we're going to leave gravity positive. So we have 5.6 times 2, and we're going to divide that by 9.8. So that's 1.142857. So that's the square root of 1.14, we'll do 286. Don't want to type in everything. So we're going to square root 1.14286, and that'll give us 1.069. So 1.069 is our time, and that's measured in seconds. Number 35. A baseball is thrown across a field, neglecting air resistance, which best describes the horizontal components of the ball's velocity and acceleration while it's in the air. How is the path of the ball best described? So it's thrown horizontally. Let's draw that out. Assuming it's going in the air and then it's coming back down. We want to know the horizontal components. So we're looking for the Vx and the acceleration. So remember, when we talked about throwing things straight down, of course they're going to gain speed. They're going to lose speed going up and they're going to gain speed going down. But that's vertical velocity. This time we care about horizontal velocity. We only care about the velocity going horizontally. And if you remember in all of those videos that we watched and all those problems that we talked about, horizontal velocity, which is Vx, It does not change. It stays the same. Yes, Vy changes, the vertical velocity going up and down, that changes, but horizontal velocity will never change. The same thing as is acceleration. The acceleration is always going to be the same for anything in the air. It's always going to be negative 9.8. So the acceleration, which is g for gravity, and horizontal velocity, Vx, does not change. It stays the same. Both of those always will stay the same. Again, Vy changes, but Vx and acceleration, which would be gravity, never changes. And finally, the last one for Unit 3. A basketball with a mass of 3 kilograms is thrown horizontally from a tall tower with a speed of 20 meters per second. The ball lands 15 meters from the base of the tower. How tall is the tower? So we got a couple of things going on here, but one thing we don't need to know is the mass. Mass is not affected by gravity. Don't even pay attention to that number. It's thrown horizontally with a speed of 20, but since it's thrown horizontally, that's our Vx. The ball lands 15 meters from the base of the tower. It doesn't land 15 meters below, it lands 15 meters from the base. So that means that is our dx, our horizontal distance. Not our dy, but our horizontal distance. We're looking for how tall is the tower. So we're looking for dy. If you look at the dy formula, you'll notice that it has time. It needs time. We're not given time. So the first thing we're going to need to do is solve for time. All we have is Vx and dx. So we're going to need to rearrange our formula to help us solve for time. So let's use the dx equals vxt formula because that one's easier to manipulate. Dx equals vx times t. We know our dx is 15. We know our velocity Vx is 20. And we're looking for our time. All we have to do is divide 15 by 20. 15 divided by 20, our time is 0.75 seconds. .75 seconds. But again, we're not done. That was just the first part. Now we're going to do the second part, which is solving for dy. dy is gt squared over 2. Gravity is always 9.8. Our time we just calculated, that's 0.75 squared. We're only squaring that time. And then we'll divide by 2. So 0.75 squared, multiply that by negative 9.8, divide by 2. Our dy would be negative 2.75625. So remember I talked about distance being negative. It doesn't have to be. If you wanted to, you can take off that negative. It's only negative because it was going down in the downward direction. But you could put a positive 2.756 meters. Don't worry about doing it on the test. If you put a negative, you'll still get the same answer. If you don't put a negative, you'll still get the same answer. They'll both be counted right, as long as you did it correctly. So that's all I wanted to talk about for Unit 2 and 3. I will post a video about the Unit 4 answers next.